Hey guys, I'm going to do an example on how to do a projectile calculation for you. So I've already drawn this on the board. I have a projectile which is going to launch at 30 degrees and have an initial velocity of 65 meters per second. So I'll show you how to do this math. So the first thing we want to do probably is set up a table so we can look at the difference between the x and the y values, the knowns that we have, and the unknowns. So I'm going to just label this x and this y. So the projectile motion is a vector. So we can take a look at this and we can figure out its x component and its y component. The x component of this is just equal to, this part here is just the cosine of the angle times the initial velocity, and the y component is equal to the sine times the sine of the angle times the velocity. So let's go on and put that down here. My initial velocity in the x direction is equal to the the velocity, 65 meters per second, times the cosine of the angle, which I said was 30 degrees. And if I plug that into my calculator, I'll find that Vx is equal to 56.3 meters per second. So that's my initial velocity in the x direction. The initial velocity in the y direction, let me do this in a different color, Vy is equal to 65 meters per second times the sine of 30 degrees, and that's going to be equal to 32.5 meters per second. So Vy, the velocity in the y direction, or the y component of velocity, is going to be equal to 32.5 meters per second. So now I want to find things like how high does the projectile go, how long is the projectile in the air, how far does it go. So these are all things that I want to calculate. But there's not a lot that I can do until I know how long the projectile is in the air. So I'm going to label a couple of points. I'm going to label this point at the top of the arc. I'll call this T sub 1. And I'll call this point right here T sub 2. Should make that a lowercase. So T1 is at the top of the arc, and T2 is when it hits the ground. So solving for T1 is the first thing that I can do because I know the y component. It's the same as if I threw something up in the air and then it fell back down. How do I find out how high it goes? Well, that's the same as finding out how long it takes to hit the ground. If I dropped it from up there, I can use all kind of equations, but let's use this simple equation right here. I'm going to say the velocity, the final velocity in the y direction is equal to the initial velocity in the y direction plus at. And remember that a is our acceleration due to gravity. So I'm going to change this to, since g is negative anyway, I'm going to change this to minus gt, with g being 9.8, negative 9.8, or g being 10. For our purposes, we'll just approximate. So in this case, I can rearrange this equation. Remember that the final velocity here is 0. If I shoot the ball or the projectile up at the top of the arc, its y velocity is 0. So if I look at this head on, I see this go up and I see it come down. And the top of the arc, that's T1. So my final velocity is 0. And if I rearrange this, I end up with T is equal to my final velocity minus my initial velocity divided by A, which is equal to my 0 minus my 32.5 divided by my minus 10. So my time, T1, is equal to 3.25 seconds. So T1 is equal to 3.25 seconds. Now, what can I do with T1? Let's That's where it's at its peak, so I can use it to calculate height, but I can also use that on the other side to calculate range, because what is T2? T2 is twice T1. The amount of time it takes to get to the top is equal to the amount of time it takes to get to the bottom. So I can say that T2 is equal to 2 times T1. T2 is equal to 2 times 3.25 seconds. So T2 is equal to 6.50 seconds. So that is how long it's in the air total. And then I can get the range because I know that the distance in the x direction is equal to the velocity in the x direction times the time. Remember, there is no acceleration in the x direction, so it's just constant velocity. So dx is equal to my initial velocity up here was 56.3 meters per second. So 56.3 meters per second times 6.5 seconds. And when I multiply all of that out, I end up with dx is equal to 366 meters. So this is my range right here. And I got that from my initial velocity in the x direction and the time, which is the same for both. So what about the height? The height is the only other thing we haven't really gotten to. So I'll switch colors and come on over here. There are lots of equations that we can look at for height. The distance equation, where we can say distance final is equal to distance initial plus initial velocity times time plus 1/2 AT squared. This is really long and involved. My initial distance, I'm shooting from the ground up and back down to the ground. My initial distance is 0. My initial velocity, this velocity they're talking about isn't the velocity that it was shot at. That's the velocity that it had before it started accelerating, which was 0. So this goes away as well. So I end up with my distance being equal to 1/2 AT squared. Now my acceleration, this is going to end up with a negative number because this is the thing I might use if I was to say drop it from the top and it's falling down, which is the same as going up. So really I'm looking at the absolute value of this number for the distance that it covers. It's the same distance going up and the same distance going down. Doesn't matter. But my distance is going to be equal to 1/2 times my gravity, which is 10 meters per second squared, times t. Now this is t1 because I'm looking for the height, how tall it is. So t1 is 3.25 seconds, and then I'm going to square that. That's a decimal point right there. And if I do all of that math, when I'm done, I end up with the height being 52.8 meters. The seconds squared cancels with the seconds squared. So my d in the y direction, that should be y, is 52.8 meters. Is there an easier way to do this? Yes, there is. Actually, we can look at another equation. We can say that the distance is equal to the average velocity. So that's vf plus vi divided by 2. That's the average velocity times time. And if we do that, we end up with our average velocity. We had our initial velocity was 32.5 meters per second. So we have, and our final velocity is 0. So we have 0 minus 32.5 meters per second divided by 2. Then we multiply that by 3.25. And we end up with the same thing. dy is equal to 52.8 meters. Hope this helped.